So the first application of the programmable interval timer 8253 IC is that it can be used to interrupt a time sharing operating system at evenly spaced intervals so that it can switch a program. Now the programmable interval timer, it is a timer which is providing the time delays at certain equal intervals of time. Okay, so we can use this timer IC for providing the interrupt to a time sharing operating system like a microprocessor or any central processing unit. We can use this time sharing operating system. It can be like microprocessor is there. So we can use this timer to interrupt the microprocessor at evenly spaced intervals. Because the timer, we can initialize this timer with a count. We can load the count into this timer, and this timer, it is going to decrement this count until its value becomes 0. So the time taken to decrement this count till 0, that time delay will be provided by this timer. Okay, so at the end, when this count has become 0, this timer, it is going to generate a pulse. Or we can set that when this counter has become 0, then interrupt the microprocessor. So we can use this timer to provide the interrupt to the microprocessor at evenly spaced intervals so that it can switch a program. Because microprocessor was currently doing some operation and we have provided the timer with the count. Now the timer, it is going to decrement the count, and at the end, when it has become 0, it will interrupt the microprocessor. So the microprocessor, it is going to stop its current operation, and then it is going to execute the subroutine. Okay, so this is the first application of the programmable interval timer IC 8253. Now comes the second application. The programmable interval timer, it can be used as a one-shot generator. Every time we are writing that programmable means that we can write a program, we can write some instructions, so we can have a software control over this. Okay, so programmable one-shot generator, we can use this interval, this timer IC. What this one-shot generator means that it is going to generate a pulse every time this count has become 0. Okay, so whenever we want to have a pulse in any circuitry, then we can use this timer IC. So we write that it is used to generate a pulse So I'm writing here that it is used to generate a pulse after a delay of desired period. Delay of desired period means because if we want a pulse at every 10 seconds time interval. Okay, so we are going to load a count which is equivalent to a 10 seconds time delay into the counter, into this timer, and this timer, it is going to decrement that count. So this timer, it is providing the delay of 10 seconds which we want, and after the delay of 10 seconds, it will generate the pulse. Okay, so that is why I have written here that it is used to generate a pulse after a delay of desired period. So whatever delay period you want, you can load the equivalent count into the timer, and then after this count has become 0, that pulse will be generated. That is why we can use this programmable one shot generator. One shot is used for one pulse. The next application is that it can serve, this IC can serve as a programmable baud rate generator. Baud rate means bits per second. Okay, so how many bits are being transferred per second? So this IC 8253, it can be used as a programmable baud rate generator. Now when microprocessor, it is performing the serial communication, so in serial communication the data is transferred. Okay, the data can come in towards the microprocessor, and also it can send some data. Now how many, because data it is in the form of bits, data it is always in the form of bits. So when the data is transferred in the form of bits. So how many bits are transferred per second? That is called the baud rate. So this 8253 IC, it can be used to generate high frequency pulse train for setting the baud rate in the serial communication. Okay, because it is generating a pulse train every time when the count has become 0, it is generating a pulse. So if we want to generate a pulse train which is having a specific frequency, like this type of pulses we can generate through this 8253 IC. So this high frequency pulse train can be used for setting the baud rate, that is bits per second, in the serial communication. So this was the third application of 8253. Next we have So the fourth application of 8253 is that it can be used to measure the time delays between external events. Suppose some event is occurring at some specific time interval, so that time interval can be measured by 8253, because due to the high frequency input to the timer, the 8253 it is working at a frequency of 0 to 10 megahertz. So due to the high frequency input to the timer, it can also be used to measure the time interval between two events. Okay. Then we have the fifth application is that count the number of time an event occurs. The most common application of 8253 is that it is used for the timing and counting operations. So all the operations or all the applications which involve the counting of the events or counting of the time interval, measuring the time interval, all will use the 8253 IC. So here we have the another application of 8253 through which we can count the number of time an event has occurred. Now, how we can count that the number of time an event occurs? Every time whenever an event occurs, if the system is generating a pulse, so the counter, the timer IC, it is going to count the number of pulses, and the number of pulses will be equal to the number of times that event has occurred. So in this way, the number of times an event has occurred can be counted using the 8253 IC. The next application is that it causes the processor Now, if we want that, if we want to interrupt the microprocessor after performing some task, then we can use the 8253 IC. When the microprocessor, when the external events they are occurring, then when the external events they are completed, then this 8253 IC it is going to generate a pulse, and that pulse is going to interrupt the microprocessor. So we can this 8253 it can cause the processor to be interrupted after a programmed number of external events have occurred. Suppose we want that there are n tasks, and after half of the tasks are completed we want to interrupt the microprocessor. So we can use the 8253 IC in such type of applications. And the last application is that it can be used as a real-time clock. Because real-time clock we can use here because this is generating the pulses after every fixed interval of time it is generating. We can set that time interval in the count. We can initialize the count with that, and every time the counter has been decremented it will generate the pulse. So this time interval it can be fixed and it can work as a real-time clock. So these are the applications of the programmable interval timer IC 8253. So I hope that this topic is clear to you. Thank you.